Hello guys, I hope you are doing very well. I'm going to solve a question that was in a quiz for you. Here we are in this chapter. We want to solve this one. We have a plate, the plate of 15 centimeter. It means this is the 15 centimeter that we have. This is the plate. And this is going to be inside this shaft. So the width of this plate is equal to 15 centimeters or 0.15 meter, and the length is given to us. The same is in the bottom. I want to pull this plate out of this between these two layers. So we have liquid at A, we have liquid at B. It means that Y at A is equal to 6 millimeters and Y at B is equal to 4 millimeters. So if I want to calculate the force, first of all I know that due to the force, due to the friction that we have, due to the viscosity forces, we have a shear force. This is the shear force, and this shear force, this is belong to tau A, and this is called tau B. Tau, it means the shear force, or the tau is equal to shear stress, and it's equal to force divided by the area, and this is the parallel area to the force, the acting force. Now I know that the area for each of them is equal. Area is equal to the area of the plate, which is equal to 0.2 times 0.15 meter, and this will become 0.03 meter square. Now what I want to know is because we have different depth and we have the force that's acting on the force is equal to, we have a rule, the tau at any point in this force is equal to, before going to solve this one, we know that due to summation of the fx we are equal to 0. It means that summation fx equal to 0. It means that P will equal to the force that will be exerted here. We will have, due to that tau A, we will have a force which is named Fb, and due to that shear stress of A, we have a force called A, because tau at A is equal to force at A divided by area, and tau at B is equal to force at B divided by the area, and the area are the same for both. So in general, summation fx equal to 0, it means that P will be equal to Fa plus Fb. Now how to find the Pfa and Fb? We have the viscosity, which is equal to due to the viscosity, tau at any point will equal to the viscosity du by dy, or the velocity by dy, which is equal to viscosity times velocity times y. This is velocity, and this is the thickness of the fluid layer. It means this will represent y, and this is the thickness. Viscosity, it is the liquid that we have it here. Now for the top layer, which is the A layer, so tau A will equal to the viscosity at layer above, which is viscosity at A, times velocity, the velocity of the plate. We know the velocity of the plate is equal to 6 millimeter per second. Okay, so this is the velocity. So this plate will go out with a velocity equal to constant velocity 6 millimeter per second. So I want this one, and we have to know y at A. So for that reason, tau A is equal to viscosity at A, and the viscosity at A will equal to 0.03. Viscosity of A is equal to 0.03 Newton second per meter square, and viscosity at B is equal to 0.01. Viscosity at B is equal to 0.01 Newton second per meter square. Now I'll go back to the equation. Now, okay, so P 0.03 A. Now viscosity at A will equal to 0.03 times, this is Newton second per meter square, times the velocity of the plate. The velocity of the plate is equal 6 millimeter per second divided by the y, or the depth of the layer, which is also for A is equal to 6 millimeter. So do not need to change the convert, they are all the same, and the second with the second will go, so the result will be in Newton per meter square. Now so the result is equal to 0.03 meter per second. That means, then it means the force at A will equal to tau at A times the area, which means the 0.03 Newton per meter square times the area of the plate, which is equal to 0.2 meter times 0.15 meter, and the result is equal to 0.0009 Newton, and it means about 0.9 milli-Newton. This is for FA. The same for FV. I will go and do the same for FV. So for FV, I will say tau at B is equal, in this layer, is equal to viscosity at B times U, which is the velocity of the plate, divided the depth of the B, which is here YB. Now this will become tau U, viscosity of B, which is 0.01 Newton second per meter square, times U, the velocity of the plate, which is 6 millimeter per second, divided by the depth of layer B. Here we have 4 millimeter. So again, we don't need to change anything. Now, okay, so the result is equal to 6 divided by 4 times 0.01, which is equal to 1.5 times point, it means 0.01. It will equal to 0.015 Newton per meter square, and then F force at B is equal to tau B times area, and it's equal to 0.015 Newton per meter square multiplied by the area. The area is equal to 0.15 times 0.2 meter square. So by multiplying 0.2 times 0.15, so the result is equal to the force at B is equal to 0.00045 Newton, or it means it's point 0.00045 Newton. It means it's about 0.45 millinewton. Now we have both, so I can say then the value of P is equal to force at A plus force at B, which is equal to 0.9 millinewton plus 0.45 millinewton, and it will become 1.35 millinewton. This is the result of the answers. Thank you very much for having this question, and here's the answer. I hope it was interesting to you. Thank you very much.